Okay, so what I want to talk about is roughly factor with what the book calls the AC method. Okay? So we might recall how to factor otherwise, right? So kind of otherwise we had this problem that was factor x squared plus something like bx plus c, right? We learned this yesterday. And we thought to ourselves like, oh, we should look for two things that kind of, oops, not and, more or less what? Add to b, like add or subtract, right? To b, and what to c?
Multiply.
Multiply to b, c?
Is it just multiply, not multiply and divide?
It's just multiply, but it's multiply maybe with a plus or minus, right? We kind of only concerned ourselves with like the size of c and the size of b, and then in the process we had to fiddle with these plus or minuses, right? That same kind of thing is going to continue today, but our problem is going to be, so this new thing, right? And I'm sure you'll notice what makes it different is we would like to factor something that looks like ax squared plus bx plus c. Does that kind of make sense? You guys see the difference between the thing we did the other day and the thing we're going to try to do today?
The A.
Yeah, it's really just that there's this a now, and now we can't just add or subtract to b and multiply to c. We have to account for the a somehow. Cool? So the AC method works this way. We look at something like this, and we say, okay, it multiplies. We kind of look for two numbers that multiply to be AC and add or subtract. Oops. Right? To B. This seems weird, right? The only difference is that instead of just considering C and thinking about what multiplies to be C, I took A, multiplied it by C, and then thought about that instead. Cool? This seems like it's going to be stupid easy, right? There's a little subtlety here. It takes just a second. So let's see if we figure one out. So here's an example. Let's do factor 6x squared plus 7x plus 2. Cool? All right, so I think to myself, I need to multiply to be I'm just going to stand here staring at each other. Okay, so if there wasn't a 6, right, I would be looking for things that multiply to be 2 and add to be 7, right? Since there's the 6 there, I'm going to look for things that multiply to be 12. You guys see where I got the... Okay, so I'm looking for multiply to 12, add to 7. Okay, see that? Okay, so what multiplies to 12 and adds to 7? 4 and 3 seems to, right? Okay, now the trick with this one is that you take, right, I find 4 and 3 seems like a really good candidate for this. So the trick to actually doing the silly thing, once I've found these, is I say, okay, I can write 7 as 4 plus 3. So I've got 6x squared, right? I'm just thinking this is what I started with. And I'm going to write 7 as 4 and 3. Okay, see that? Cool. Okay, so now out of one pair here, you'll be able to factor something, assuming this is going to work. So I notice I've got a pair here and a pair here. Can I factor something out of this pair?
2x.
Yeah, you'll always be able to pull an x out, and then there will be usually some kind of constant. So I can get a 2x out of that thing. You guys see that? What am I left with in there?
You get 3x and then 2.
You get a 3x plus 2, and then over here there was a 3x plus 2. You guys see this? This is something that your book calls factor by grouping that I didn't teach you at the time because I feel like factor by grouping is really part of this. Factor by grouping is usually super awkward, but it happens to be the thing you want in the AC method. Okay? So this is a technique that your book teaches kind of on its own, and I don't want you to even know that this is a technique on its own. I just want you to know, okay, when I do the AC method, I write the middle as the kind of broken into the two numbers I've selected, right? And then I factor everything I can out of the left two things and factor everything I can out of the right two things. Everything I could factor out of this happened to be 1, right? Can you see that? Okay, now, out of the common stuff, do we notice that we have this guy repeated twice?
Yeah, so you can just write it as 3x plus 2.
Okay, so I can factor now a 3x plus 2 out, and what am I left with?
You get 2x plus 1.
You guys all see that? This piece is 2x times a 3x plus 2, and then I'm adding that 3x plus 2 times something else. So I can pull that out of both pieces, and I'm left with a 2x from this piece and a 1 from that piece. Okay, see that? And now I've factored by grouping. That's done. Or, sorry, factored by the AC method. You guys want to see another one?
Yes, please.
Okay, let's try another one. Any questions on that? Does that follow? The especially tricky bit is this factor at the end, right? That one was weird because I was factoring a quantity out. But it happens in all of them, so don't get like, yeah, it feels funny, but it's going to happen every time, so you'll get used to it pretty quick, I think. Okay, so let's factor another one. So let's factor 7x minus 15 plus 2x squared. Okay, so first things first.
Write in standard form for all of them.
Yeah, this is in sort of an awkward order. Let me rewrite it. So I'll rewrite this as what?
2x squared plus 7x minus 15.
Very nice, guys. Okay, so I rewrite in standard order. Now what am I looking for?
You're looking to multiply 2 and 15, so that'd be like negative 30. Oh, is it
So
30?
Yeah,
Yeah.
so I'm looking for multiply to 2 times 15 is 30.
And add.
Yeah, really I'm looking for negative, but we'll come across that in a bit. So we could say negative 30, that would be fine.
And then you
Okay.
add to get 7.
And we add to get 7. Right? Is there something like that?
10 and negative 3.
Okay, see that? So I might think about 30 in lots of ways. So I might think, okay, 30 is 6 times 5, or 30 is 3 times 10, or 30 is 30 times 1, right? This is maybe the hardest step with this one, or it's 15 times 2, right? There's a whole bunch of ways for me to make 30, and I have to check all of these, right? The one that has 7 seems like this pair, right? Okay, so what do I do?
You can like factor like a common thing out.
Okay, first I want to re-express the middle, right? I want to think about this 7 as 10 and 3 somehow, right? Okay, so I want to take this thing and rewrite as
10x
2x squared
plus 10x, positive 10x, and then minus 3x.
You guys all see that? Okay, and then I've got my minus 15. Okay, then what?
Then you can factor like do the pairs. Yeah. The two
Okay,
pairs.
so I've got this pair and this pair.
So you can.
Good job, Jacob. 2x would come out of the first one.
Okay, I can get a 2x out of this first one. What am I left with there? Good, high confidence. Okay, I got 2x plus 5. Somebody else, what can I factor out of the other one?
3. Negative 3.
Negative 3. And what am I left with in there?
Plus
X,
5.
what, 5?
Plus, that's what I said.
Plus 5? Okay, and if we're not sure on our factoring, what do? Yeah, distribute it back through, make sure you get the same thing you had, right? You guys are better at distributing than you are at factoring, right? Most people are, including me. So when I factor something, I just multiply it back up to make sure I did it right. It's easy for me to lose a minus sign. It's easy for me to also pick it up if I multiply it back out, right? I'll notice I lost it. Okay, now what do I do?
No, you can take out one of the sections for the next.
Yeah, okay, so first things first, you factor everything you can out of the left, everything you can out of the right. And then if factor by grouping, if the AC method is going to work, you'll have something common between these two pieces. This thing will be the same. And you can then factor that out. Okay? So I'll factor out an x plus 5. What'll I be left with?
2x minus
2x minus 3. Very nice.
3. And that's your answer.
And that's my answer. I've fully factored this now. You guys see that? You guys want to see one that has trouble? Okay. Let's see if we can make one not work. All right, so let's try this one. What are we looking for multiplies out to?
12.
Okay, we're looking for multiplies to 12.
Adds to negative. Or, yeah, adds to 5 or we put a negative.
Adds to negative 5, right? Okay, so 12. Let's see, how can I write 12? I can write it as 1 times 12.
3 times 4.
I could write it as 3 times 4. I could write it as 2 times 6. Is there another one? This is the step where you can miss one, right? And if you miss one, then you might end up screwed. So if you need to factor 12, factor it fully, right? So 12 is 2 times 2 times 3, right? And then think about how many ways are there for me to grab 2 pairs out of this. Maybe 1 times. So if I'm going to make numbers out of this, right? I've got this one, that's 1 times 12. Or that one, that's 2 times 6. Or this one, that's 4 times 3. And there actually aren't any more ways for me to select anything different out of that. You guys see that? So fiddle around with that a little bit if you need to make sure you've got all the pairs. And then we're asking, okay, they need to add to negative 5. What can these two add to?
5, or 7, or 1.
Okay, see that? 7 or 1 plus or minus, that's all I can get out of the 3 and 4, so that one ain't going to do it. How about 1 and 12?
You can get 13 or 11.
Get 13 or 11, plus or minus, right? That's still not 5. 2 and 6?
You can get 8 or 4.
You can get 8 or 4.
So it's factorable.
I can't factor it conveniently, at least. This method doesn't work on it.
You could take a 1 out.
We could take a 1 out. What do
You
you
could
mean?
write it as 3 different x's, but I don't think that works.
3 different x's.
Oh, no, man, I guess you can.
Yeah, you can't factor this into 2 things conveniently. This is just, whoops. We actually have a word for this. We call them prime when you can't factor them. This one happens to be prime. Yeah, and that's fine. Remember, sometimes things don't factor conveniently. You have to use a more advanced method to do whatever you're trying to do to it. Sometimes that means we just couldn't do this one with the equipment we have. That's really okay. That's what Chapter 8 is about. Cool. So this class is kind of broken in a strange spot because we kind of learn to factor and then we learn to use the zero product rule. And then we don't learn to use the quadratic formula. So the tool for kind of a more robust technique would be the quadratic formula. We're not going to learn it in this class, so we're going to kind of leave you with the like, yeah, sometimes it's okay if you can't do it. Write down, whoops, didn't work. Any other questions on these? Do we want to try another one? All right, let's try another one. Okay, so let's see if we could factor 600 minus 800t minus 800t squared. Okay. Wow, super scary, right? Okay, so I should rearrange maybe?
Negative 800t squared, that's what I said.
Good.
Minus 800t plus 600. Good job, April. Thank you.
Okay, now here's a question for you. Do I want to deal with factoring or trying to wonder what 2 things multiply together to be 48
Could you just take away the
times 10 to the how many?
Could you factor out 100 and then 12?
Definitely.
That's exactly what you said.
In fact, we should do better than factor out 100. We should factor out 200. You guys all see that? If you factor out the 100 first, which is fine, right? Maybe I would even factor out negative 100. Why would I do that?
Because then they would all be positive.
Yeah, because for some reason I do better when the squared thing has a positive on it, right? Okay, so I might factor out negative 100 first. Then I'll be left with what? We have 8t squared plus 8t's plus,
Minus. Wait.
good. I factored out a minus, right? So that plus is going to be a minus, and that should be a 6. And then I should check and make sure when I multiply this back through that I get the right thing. So I got minus 800t squared, minus 800t, plus 600. Good? Okay, and now I might notice, oh, I can still get something out of this. I can get a 2 out, right? So this is minus 100, and then I'm going to pull another 2, right? What am I going to be left with?
4t
4t
squared
squared
plus 4t
plus 4t
minus 3.
minus 3. Very nice. Now what? Okay, now we do this weird thing that we sometimes do, right? Which is, okay, new problem, right? Right, now my new problem is going to be factor what? That. Which part of this? Yeah, really you could get away with just factoring this part, right? And then we'll have to remember to multiply by our negative 200. Okay, see that? But when I'm doing the AC method, I'm bogged down enough with the new method, so I'm just going to factor this piece. So this one's my new problem. Right, we're going to factor 4t squared plus 4t minus 3. Good, cool that? Okay, so what am I looking to multiply to? And add to 4. Really, I was looking for negative 12, right? Okay, so what are the factors of negative 12?
6
Maybe
and
let's
2.
just do 12. 2 and 6, 3 and 4, 1 and 12 again. 1 and 12 gives me differences of 11 and 13, that ain't going to work.
1 and 7.
1 and 7 ain't going to work.
You get 4 and then 8.
4 and 8, okay, that's the one I want. Right, so 2 and 6 is my choice here.
Should be positive 6 and negative 2.
Ah, okay, so I need minus 2 plus 6, right? So I need 4t squared. Does it matter which order they go in?
Usually just
Yeah,
just
because it's
smallest.
minus.
It doesn't matter with you.
Doesn't it matter? I keep grouping them by pairs, right? Did you guys see that? It feels like it should probably matter.
But if you're just...
It doesn't.
Yeah, because you're just foiling back out anyway.
Okay, so it doesn't matter how you get, right, which order I write this down in. So I'm going to write down minus 2t plus 6t, right? Just because it's backwards of what most of you would write. Yeah? So you all could try this on your own, and you'll see that you get the same thing if you write down what you would normally. Okay? And then I've got minus 3.
And then you group them.
Okay, so we want to group, so we're looking at this pair and this pair. So what can I get out of this pair?
A 2T.
A 2t. What am I left with?
Two T minus.
Very nice. You can see it? When I multiply back through, I get 4t squared, and then minus 2t. I'm wondering, right, what did I multiply by 2t to get 4t squared? Well, I needed a 2 and another t. So that's this guy. And then what did I multiply 2t by to get?
So one of this like a filler.
Yeah, the negative 1's a placeholder, right? Kind of. It's actually doing something here, though, so don't drop it. It's making that other term happen, right? Okay, out of the other piece, what can I factor?
3.
I can factor 3. What am I left with?
2t minus 1.
2t minus 1. Okay, now what?
So then you can group the 2t minus 1 together and just write them as 1.
Yeah, I can factor this guy out, right? So I've got a 2t minus 1. What am I left with?
2t plus 3.
A 2t plus 3.
So when you do it the other way, though, if you were to put 6t before the minus 2, it's the same thing, but opposite?
Yeah, if you do the, so if you swap these two, right?
And you-
Then you'll factor a 2t out of that piece, and what you'll get is the 2t plus 3 in both of them instead of the 2t minus 1 in both of them. You guys see that? It'll work either way. It's just a question of, did you multiply, like, did I put this guy on the pieces of that one? Or did I put this guy on the pieces of that one? You guys cool with that? Or this thing? Alright, so this is the AC method. Should we practice some? Alright. Question. What happens with the negative 100 and the 2? So we didn't finish this one. So what was the actual answer that I should circle for this?
With the 2?
Yeah.
Yeah, I wanted to factor this thing, right? So my original is, there's a negative 200, right? That's negative 100 times 2. And then there's a 2t minus 1 and a 2t plus 3.
And that's what it is.
And that's my answer.
So you wouldn't have to like multiply the 200 to that.
So if I multiply the 200 back in and then FOIL everything back out, what am I going to get?
600. Well,
Back to the beginning, right? In fact, I might do that to check and see if I got the answer right. You see that? But my goal was to undo all that distributing and foiling. So that's the answer I want here, because I asked for factor. Cool?